Okay, let's spend some time talking about two-way frequency tables, which are a way to display data from two different categories. So, for example, this table shows whether or not students were involved or not involved in activities, and whether or not they were male or female. So every number kind of tallies up each of those. So, for example, this one would be males who are not involved in activities. You see, and I total through columns and through rows, and also a grand total is here. So the question is, what's the probability of female who is not involved in what is the probability a student is a female who is not involved in extracurriculars? That's another way of asking the probability of female and not involved, which to me would be this part of the table divided by the total. Okay, let's take a look at another one. So the two-way frequency table is the number of male and female students by grade on the prom committee. Fill in the table. So I know that there are 3 males who are juniors, and I know there's 6 total males, so I know this must be a 3. And I know there are 7 juniors, and 3 of them are male, so 4 must be female. And females together are 6, and seniors together are 5. And all those add up. So the probability that you pick someone and as a male and a junior would be right here. 3 male juniors out of 12 on the committee. That is the total we're looking at. Okay. Now, conditional probability is a little bit more different. It's a little more precise. It's the probability that something will occur given that something else already happened. So this little line here means we can read that as given. The probability of B given A. So how does that look then for our tables? Well, if we're asked the probability that a person is a senior given that the person is female, that is info, right? That is something we already know. So we already know that we're going to be hanging out in the female column. Let's go ahead and fill in the rest of this real quick. So out of those who are female, how many are seniors? Well, the total and senior, these are my 2 numbers I'm going to look at because it's out of 6 now. It's no longer out of 12. Okay, and let's look at this again, another given example. So the probability that a person is male given their involvement in extracurriculars. So the given is that they are involved in extracurriculars. So that narrows it down to here. This is the information we were given to narrow down our scope. We're just looking at those who were male, though, in this group. So that would be that out of the total for that column. So if I pick someone from the involved in activities group, the 251, 112 of those are going to be male. Okay, so sometimes the tables have probabilities in them, decimals, instead of numbers. But the good thing is we're dealing with fractions anyways, so the ratios will still hold true. Everything we've done so far, there's no need to change any of the process. So basically we have a seminar that happened, and then the vice president of the company decided to see how that affected sales. So the question is, what's the probability that someone who attended the seminar had an increase in sales? It doesn't say the word given, but it may as well, because it's talking about someone who attended the seminar. So we're not looking at anyone who did not attend. We don't even care about them. We're only looking here. And the increase in that group was 0.48 out of 0.8, which is 0.6. You can use your calculator for that. Okay? So we're looking for that what's given. What is the underlying piece of information that we already know? The probability that someone who had an increase in sales attended the seminar. This is the underlying piece of information. This is the given. So now instead, we're going to look at those who had an increase in sales and look at them alone. And we're interested in how many attended the seminar. So this equals 0.9. So if we just look at those who increased sales, a lot of them attended the seminar, 90%. Okay. That's more, so overall it was 80%. But if we look at those who just increased in sales, we jumped to 90%. Okay. Here's another one. So this is a compare and contrast. What's the probability that a randomly selected sales representative who did not attend the seminar, that is a given. It's a piece of information that we know before our selection. Okay? So if it's given, that would be the probability increase in sales given no seminar. So we're going to look at the given. So no seminar. And we're going to divide that by, this was actually no increase in sales. Right? That's what it says here. So no increase would be the 0.18 divided by the 0.2, the probability that someone did not attend the seminar. This is a lot different than asking this, because this is not given any information, right? This is just saying, hey, what's the probability of this and this? This is looking for an intersection. And there's no circling of columns at all. We're just looking at no sales, no seminar, which puts us right here out of everyone. So basically 18%. Okay. We might want to multiply this through. I believe this is 90 out of 100. So 0.9. That seems right. Okay. So finally, here's another one that compares given versus and. So let's fill in the table. So I know this is my grand total. So these got to add up. Let's see. I know that this adds up to 60. So this better be 33. Which means this got to be 36. This needs to be 24. And this needs to be 51. So just remember that all of these add up. There's 4 totals and there's 1 grand total. They all have to add up. So it's kind of like a puzzle. Okay, so the probability of Democrat and supports the issue, that would just be simply looking at that intersection and dividing by everyone. The next one is being given info. You're given that you're supporting the issue. So we're only now looking out of 51, 51, sorry. And then we're looking at the Democrats out of those 51, not out of the 120. So honestly, that's where the game changes, is in the denominator. When we have conditional probability like this one, the denominator is actually smaller. We've learned some information that we know that can make the denominator smaller. That's kind of it. I can't even say it any other way. That's what conditional probability is about. It's about narrowing it down so that your probability, is more precise. Thanks.